Okay, so let's take a look at this new unit, trigonometry of acute angles, and 5.1 is talking about how to apply trig ratios. Now, it's very important that you understand this concept of SOHCAHTOA. So, from the word SOHCAHTOA, so means sine of theta is opposite over hypotenuse. The ka is cos theta is adjacent over hypotenuse. And the toa, the tan theta, is opposite over adjacent. So all of these trig ratios pretty much come up with a ratio between two sides. Okay, so they're making a comparison between an angle and two sides. And you got to be able to understand how to apply these rules of opposite, hypotenuse, and adjacent. So for instance, when you are labeling a triangle, you have to be able to label a triangle according to whatever angle you're talking about. So for instance, the triangle ABC. Now, B is the 90 degrees. Now, since B is 90 degrees, the 90 degrees allows us to use SOHCAHTOA. So we don't label it according to B. B just is the 90 degree angle. It allows us to use SOHCAHTOA. Now, if we want to label the triangle according to this angle here, if this is your theta, C, how do you label those sides? Well, hypotenuse is always across from 90, so that's your hypotenuse. Now, according to this angle, though, the opposite side of this angle would be here. This is the opposite side length from there to there. And the adjacent side, therefore, would be here. This side here, the one beside. Now, if I drew the exact same triangle ABC, and this was 90 degrees, and 90 degrees allows me to use SOHCAHTOA, however, I want to label the triangle according to angle A. Again, the hypotenuse is always across from 90. However, if this is my theta, the opposite side is over here. This is opposite that angle. This is the opposite. That means this would be the adjacent. So the exact same triangle, but they're labeled different because this triangle is labeled according to angle C. This triangle is labeled according to angle A. We would never label the triangle according to angle B because angle B is the 90 degrees, allows us to use SOHCAHTOA, or the Pythagorean theorem. So looking at these trig ratios, we also have to know what is the difference between the angle of elevation and the angle of depression. So the angle of elevation is the angle between the horizontal and the line of sight, or it's when looking up at an object. The angle of depression is the angle between the horizontal and the line of sight. So it has actually the exact same definition. It's between the angle, is the angle between the horizontal and the line of sight. Although elevation would be looking up, depression would be looking down. Now here's a few examples of angle of elevation: someone looking up at a plane, someone looking up at a butterfly, at a kite, and angles of depression, there's some examples as well. But I like to think of it as one example. I like to think of it as, here's a building, here's the CN Tower, let's say, and here's the observation deck of the CN Tower, and it meets at the ground at 90. And here I am at the observation deck, top of CN Tower, and here you are on the ground. Now, I spot you, or you spot me on top of the CN Tower, okay? And you see me on the observation deck. Now, whether it's me looking at you or you looking at me, this is the line of sight. Okay? So let's talk about you looking up at me first. Remember, the angle of elevation, you looking up, the angle of elevation is from the line of sight to the horizontal. This is the horizontal plane, going horizontal to the x-axis. So from the horizontal to the line of sight, this is the angle of elevation. Okay? Now, for me, looking downwards, we're talking about the angle of depression. Please do not label this as the angle of depression, because that is not the angle of depression. Angle of depression is between the horizontal and the line of sight. This is not the horizontal. That's the line of sight, but this is not the horizontal. The horizontal is actually here. And so the angle of depression would be from the horizontal, which is right there, to the line of sight. This is the angle of depression. Right there. Okay? And why are these two things have the same definition? They have the same definition because they are the same. This is actually, this horizontal are parallel. This is a Z pattern. And we know that the internal angles of a Z pattern are equal. Okay? So let's take a look at a couple of examples. So problem number 1 here. It says the CN Tower is 553 meters tall. Right there. From a position on one of the Toronto Islands 1.3 kilometers away, which is right there, from the base of the tower, determine the angle of elevation to the nearest degree to the top of the tower. Assume your eyes are 1.5 meters above ground. So your eyes are looking up at the top of the CN Tower. Now, our job is to figure out what this angle of elevation is. Now notice that this is in meters, but this is in kilometers. So the first thing I'm going to do is switch that to meters. Now kilometers, kilo means 1,000, but if you don't remember the metric system, King Henry doesn't mind drinking chocolate milk. King Henry doesn't mind drinking chocolate milk. This is kilometers, hectometers, which we don't deal with much. Decameters we don't deal with. Meters we do. Decimeters sometimes. Centimeters and millimeters, yes, we deal with a lot. So if you have 1.13 kilometers and you want to switch to meters, every time you go down 1, you multiply by 10. Okay? So you go down 1, you go down 1, you multiply by 10 again, you go down 1, you multiply by 10 again. If you just want to go down 3, you're going to multiply by, you're moving down by 3, so you're going to multiply with a 1 and 3 zeros. So it's by 1,000. If you move up, it's not multiplication, it's division. So if you multiply this by 1,000, 1, 2, 3 zeros, you're going to get 1,130 meters. Okay, so this shouldn't be written like that. It should be 1,130 meters. So this is your picture now. Okay? And so we got to look at what the triangle is. The triangle actually isn't written for you here. The triangle that we're going to look at is actually from here, straight across from his eye and straight up. This is the triangle I'm going to redraw. I'm going to redraw this triangle that goes, this is the guy's eye, this is the top of the CN Tower, and this is not the base of the CN Tower. The base of the CN Tower is down here. This is like not mid-CN Tower, but it's above the CN Tower a little bit. Okay, so we know that this distance is 1,130. We know we're looking for this angle here, theta. But this, from here to here, is not 553 meters. Remember, from here to here is 553. But remember, this little bit is 1.5 meters. So in actuality, from here to here, we can find this little bit here. It's going to be 553 minus 1.5. Okay? So this is actually going to be 551.5 meters. Okay? This is the triangle we're looking at because it's in mid-air. So be careful here. That measurement is from the top to the bottom. We're looking from the top to the eye level. So this is the triangle we're looking for. So we're looking for that angle there. Now looking at this triangle, 90 degrees allows us to use SOHCAHTOA, or Pythagorean theorem. We're looking for this angle. So according to this angle, this side length is the opposite. This side length is the adjacent because that's the hypotenuse. What relates opposite and adjacent? There is only one thing that relates opposite and adjacent from these three, and that is tan. So it's not a guessing game. We're going to ask ourselves what relates opposite and adjacent. It's tan. So tan theta is opposite over adjacent. And then continuing this, we're going to fill in the blank. So tan of theta is equal to opposite, which is 551.5, all over adjacent, which is 1,130. Now you have a couple choices here. You can either leave the fraction as is, or you can figure out what that fraction is equal to right now, but I'm going to leave the fraction as is. And what I'm going to do is I'm going to bring tan to the other side. Remember, when we're looking for an angle from last year, when you bring tan to the other side, it's tan inverse of this fraction. Now, it depends what calculator you have. If you have a calculator number 1, you can check what calculator you have. If you press tan, so like this calculator, like right here, if I press tan, the word tan shows up, meaning I press tan first, then I will open bracket 551.5 divided by 1130 close bracket, so it takes the tan inverse of that whole thing. Okay, so again tan, but this is not tan, it's tan inverse of this 551.5 divided by 1130 close bracket, and it gives me 26.0 when it's rounded to the nearest tenth meters. Okay? If you have a calculator number 2 where you press the button tan and the word tan doesn't show up on your calculator, then you have a calculator 2. What you're going to have to do is actually you'll have to press these numbers first, this divided by this equals, then press second function tan. So know how to use your calculator. Okay? So when we're looking for an angle, we're using obviously inverse tan. Let's take a look at the second problem here. An underground parking lot is being constructed 8 meters below ground level. If an exit ramp is to rise at an angle of 15 degrees, how long will the ramp be? Round your answer to the closest hundredth of a meter. So again, here's a ramp. Ramp's going to go like that, obviously. And here's the top, here's the bottom of the driveway. So it gets an exit ramp is to rise at an angle of 15 degrees. Again, an underground parking lot is being constructed 8 meters below ground level. So this is the top of the parking lot, and from here to the bottom of the parking lot is 8 meters. Okay, now we can draw a straight line across, imaginary line here, so that's 90 degrees. And it also tells us the exit ramp is to rise at an angle of 15 degrees. Angle of elevation is always from the horizontal to the line of sight. In this case, it's not line of sight, it's the car's path. So this is 15 degrees. And we have to figure out, it says, how long will the ramp be? So how long is this ramp from here to here? So according to this angle that they give us, 90 degrees allows us to use SOHCAHTOA. According to this angle, this is the opposite side. This would be the hypotenuse because it's across from the 90. What relates opposite and hypotenuse? Well, sine. So sine of theta is opposite over hypotenuse. So sine of 15 degrees is equal to opposite, which is 8, all over hypotenuse, which is x. Now, this one here, I have to solve for x. What do? First, I have to cross multiply the x. So I'll get x times sine of 15. And then I'm going to have to divide out the sine of 15 from both sides because that's multiplication. So dividing out the sine of 15 degrees, that'll get rid of it on this side. And on this side, I will do 8 divided by sine of 15. So in brackets, I'm going to do the sine of 15. And then press equals, and I will get 30.9. Okay? So therefore, the ramp should be 30.9. And then B, it asks us what is the horizontal distance to the nearest hundredth of a meter. Now, it said to the nearest hundredth, sorry, so this was 30.91. To the nearest hundredth of a meter, what is the horizontal distance needed for the ramp? So it's asking us now, what is this? So I'm going to redraw this triangle where this is 15 degrees, this is 8 meters, and it's asking us for this. Let's say y. Now, according to this triangle, you have to remember that this is opposite, this is adjacent. And what relates opposite and adjacent? Tan. So if you want to do this problem here, you're going to use tan theta is equal to opposite over adjacent.